This is the next video in our exam review, and as you can see, I'm finishing up writing out some of the information that we need, but this entire chapter deals with parallel lines, and because of that, it's going to be something that we're just going to talk about the entire chapter here. The first thing is when we have parallel lines, which my parallel lines I'm going to make red so that we can differentiate them. But we have two lines that are parallel, and we have a transversal. And our transversal just crosses those lines. But this actually creates a situation where we have 8 angles, but only 2 types of angle measures. And really, we need to kind of figure out how these play together. So we have interior, which just means that we are between the 2 parallel lines. We have exterior, which means that we are on the outside of those parallel lines. So my interior angles are there. My exterior angles are there. Okay. So, at this point, what do we have? Well, this isn't the whole story, because we also have alternating or alternate, and we have same side. So our alternate angles means they're on the opposite sides of our transversal. So again, coming to here, our alternate angle, for example, for D, the alternate exterior angle is F. Whereas for my same side for D is G. But where you're located in regards to your partner, so to speak, tell us what's true about them. In fact, alternate angles are always going to be congruent. So alternate interior angles are congruent, alternate exterior angles are congruent. Same side angles, they are always supplementary. So what this tells me is that angle B is congruent to angle H, and angle B plus angle E is 180. And there's a lot of other things we can find out about it. There is one other type of angle that was not mentioned there, and that's corresponding. Now, corresponding angles, for example, A corresponds with E. They're in the same location relative to the transversal and parallel line. Corresponding angles are congruent. Okay. Now the second bit, triangles and parallel lines. Well, here's honestly what it is. We have this triangle, and I'm going to put a line here. Okay. This line and this line are parallel. So we have that situation. What does this mean? Well, this means that this angle is congruent to this angle because they are alternate interior, and this angle is congruent to this angle because they are alternate interior angles. So this is how we would prove that the angles inside a triangle sum up to be 180. However, the other big thing here is going to be, I'll extend here, in a situation like this. And I'm going to give these angles names, A, B, and I'm going to call that C, and then I'm going to put a point out here, D. What this does is it allows us to easily find the measure of this angle. Specifically, the measure of angle 1 is equal to the sum of the measures of angle B and the measures of angle A, which again makes sense. These three angles add up to be 180. These two angles add up to be 180. So it makes sense that these add up to be 180. In fact, if we were to put this in logic terms, we would have if the measure of angle 1 plus, I'm going to name this angle 2, the measure of angle 2 is 180, and measures of angle A plus measure of angle B plus the measure of angle 2 equals 180. Then the measure of angle 1 equals the measure of angle B plus the measure of angle A. Okay, the last thing that we are going to discuss here are parallel and perpendicular lines. Now, the big things are this. This is speaking strictly from an algebra standpoint. So we have two parts: identification and creation. So our identification, well, if lines are parallel, they have the same slope. If lines are perpendicular, they have slopes that multiply to be -1. Or another way of saying that is that their slopes are opposite reciprocal slopes. So, how can we apply that to actually writing equations of lines? Well, we're going to write both a parallel and a perpendicular line here. And we're going to write it to this line. Notice this line is in standard form. And you can have lines in standard form, or point slope form, or slope intercept form. If you don't know the slope, and you don't remember the tricks to find the slope, you can always just solve for y. And that's going to give us y equals -4x plus 2, meaning my slope is -4. Okay, for my parallel lines, I know that my slope is going to be the same, but I'm going to go through this point. So I have my slope-intercept form. I want to know what b is. I have a slope, an x, and a y. So 7 equals -4 times 2 plus b, and we can solve this out to end up with positive 15 is b. So y equals -4x plus 15 is our parallel line. Our perpendicular line. Our perpendicular line has a opposite reciprocal slope, so that's going to be a slope of 1/4. And it passes through the same point, so 2, 7. Now we could do exactly what we did over here, and that be fine, or we could use point slope form, which is what we'll do. So all we have to do here is plug in the information we have. Y minus 7 is equal to 1/4 x minus 2. If we want, we can solve this out into slope-intercept form. We can also leave it like this if we're not told a specific way to write the line. So that really depends on the problem. Anyway, that will do it for this video, and I will see you in the next